Misplaced my hat again. Damn it. I honestly need to get a new one because it's got a hole in the top. There's a whole lot of things I gotta get new things of. Welcome to the end. It's the end of 2025. Got a lot of music. I've got a lot of music I gotta get up. Let me do my usual thing here. $2025. Oh yeah. We did it. We survived. We made it to the time where it transitions into the next one. And I thought, I'm fucking around with these buffer overflows. And it's a good time because we're about to overflow into a new year. I have to set up the thumbnail because it always forgets to get my thumbnail. Oh, damn. I don't like that thumbnail because it's too big. Okay. So let's scale it. Yeah, actually, you know how we can scale it? We can export it as a JPG. And that should be very small in comparison. Yeah. Nice. I don't do as much hacking content as I do game development. Now I think about it. All right. I think I've got everything set up here. Time to get started here. It's time to get started. It took me a while to figure out what the fuck I was doing wrong. And I finally figured it out. So we're going to walk through this together. I'm going to speak it out loud because at the end of the day, in the first pass of understanding something, I'm very non-verbal in my approach. It is only after the first pass that I go back through the process again and then I speak it out loud. So it kind of confirms to me that I understand the concepts in general and can communicate them to other people. I've done this enough with programming that I've made a living off of it. Somehow. I don't know how that works. I do kind of get how computers work, though. I say kind of because I don't want to pretend like I know everything. But there are parts of the computer that I want to know more about. Things that people have not really paid me for. While I have walked through buffer overflows a number of times at this point, I wish it were a more regular part. I wish it were more a regular part of my programming routine. So one of the problems that I ran into in developing a shell script, for instance, is very common to use a scripting language to assist in the generation of a shell script or a shell code to begin with. Writing shellcode is tedious and annoying, and there's not like fantastic tools that help you do it like we have regular programming things. So that's like a problem, right? So we get to a point where we're like, okay, we got this program. We got this super basic, dumbass program that we've just kind of set up here. It's a basic C program. Let's see. Do I ever have a universal C-lang format set up here? Okay. I decided recently I kind of like 4 spaces between functions. The extra space really assists with visibility. So super basic program, right? We've got a int main, calls my fun, then it does return 0. My fun has a buffer called name that is 16 bytes long. Not very big at all. Then we have a print statement, and we have another print statement. What happens when we compile it? We get a lot of warnings. Warning, char fgetS, writing 120 bytes into a register of size 16 overflows the destination or region of size 16. Note destination object name of size 16. So the problem there is that we are reading 128 bytes into a space that was only designed for 16. So we're intentionally overflowing the buffer here, right? Like I wrote it to kind of demonstrate like what goes wrong when a programmer is being sloppy. A lot of people talk about like when you first get introduced to buffer overflows to begin with. There's this super old function called getS. And this is usually like what people point to as like the entry point to like educational buffer overflow material. But I thought, you know, this would be kind of a cool opportunity to show that like a commonly taught function, or at least fgetS was like kind of like a standard when I was in school. But I never thought that you could actually just like intentionally read more than 128, right? Now, I believe that there is a flag that like allows you to like ignore warnings, but we're not going to do that here. So they actually print the error twice, or the warning. It doesn't prevent it from being compiled though, which is very scary. However, it is this scary broken program that will be the basis of this demonstration, right? Because the whole idea is I'm kind of like building out like a CTF type thingy. Eventually, flag up here is going to be something a bit more robust. Maybe even something that you have to kind of reverse engineer. It's like, if you wanted to hide a flag in a binary, like for instance, see, the word flag shows up. It's not very well hidden. But there's this really good paper. I'm going to pull it up now that I'm thinking about it. Damn, this is a good track. I'm gonna have to restart these from the top because I'm generating some new ones. But this is like my KMFDM type chill out music. I'm just now creating it. It's like brand new. Are you fucking serious? Spectrum is blocking VX Underground. I'm gonna have to be on a VPN to get at it. Oh, wait, no, it's org. Okay, they're blocking .com, but they, like, allow the .org. That's funny. That's funny as fuck. Okay. There is a very specific paper I need to pull up right now. It's actually a really cool one. I'm gonna download it and then like load it in the terminal. I also actually have in the other terminal smashing the stack for fun and profit. Here we go. Okay, we're gonna actually load this up in a okay. So here's the idea, right? Using constant expression in C++. At compile time, you can actually take a string that you pass in through source code that in the resulting binary is actually encrypted or ciphered somehow, right? Like, in this example, you have to pass in the size of the string that you're creating, like how many characters it takes up. So in this case, because HELLO null character, that's going to be 6, right? But I want to play I want to play around with some of the ideas here, because we could literally, and I'll give credit, obviously. But you could basically take something like this, right? Oh, wait. Yeah. Oh wait, no. All right. I wonder how this is going to impact the actual injection, but it's going to be the kind of thing where I need to start like adding this in, right? So we're not really ready to use it, but I'm just kind of getting it ready. Because eventually, once like I work out the shellcode perfectly so that we can actually hop in the island and like print the flag, I want to add in like a check so that if you enter the flag correctly, then you know, you get like a yay, you did it type message. I think that would be cool. Alright, so let's start with this, right? It prints two things that like don't really give you any context. So the name of the game is you want to get to the island. And we're going to grow this thing over time. Now, with regular compilation, we have, you notice that the address of name is changing every time we run the program. What does that mean? Well, this thing called ASLR is activated. However, over here in my right terminal, I have temporarily disabled ASLR so that when we actually run the program, address of name is going to be fixed. As well as island. Island is already pretty fixed because we're compiling things with no I, which has to do with like how the address of functions gets assigned and randomized whenever you actually like run a program. So nothing happens when I type Mike, right? Nothing happens if I type 8 A's. Nothing happens if I type 12 A's. What about 16? Nothing. $20 A's. Nothing. What about 25 A's? Aha! We got a segmentation fault. Or dump. So what exactly happened there? We're going to load up GDB for this one. GDB, oh wait, no, actually we're going to load GDB up over on the right hand side. And we're going to set a breakpoint on main, or no, f-get-s. We're going to go and run the program, and we're going to feed it an input. Payload A's. I see that I'm gonna end up having to move my stuff around a bit. So the program has hit a breakpoint that I just set. I remember over in the actual program, we had this call to f-get-s right here. So over in the right, in the debugger, we actually have a breakpoint set on that right now. So let's step, which goes through to the instruction immediately after the f-get-s. Over in the C code, we don't have another function after the get-s or the f-get-s. So you can imagine it's preparing to return in the main. It's preparing to return to like right here. So what happens over here? So add ESP10, right? So ESP10 points to something else that points to my big long string of A's that I input. So let's step single instruction, single assembly instruction. It's going to go from here to here. Now, let's step a single instruction. Let's step a single instruction. And now it's about to call return. So nothing particularly fancy happened here, right? But it does segfault. So what happened? Payload 0.txt is going to be the first thing that we use as a measurement stick. Here's how that works. We're going to rerun the program with payload 0 as our input this time. We hit the breakpoint on fgetS again. Or step past it. You can see our content on the stack right here. Notice that EBP is pointing to BBB CCC. So we're going to step a single instruction. ESP's address now points to the beginning of our input. The leave function is about to get called. Notice that EBP gets overwritten with our BBB. Notice that EIP also gets overwritten with our CCCC. Ooh. Shoutouts to everyone who's watching right now. Happy New Year's Eve. All right. So what happens if you step again? Segfault. Because naturally, EIP no longer points to a valid instruction. However, what I didn't realize earlier was that this space right here is not enough to hold the whole shellcode. And by the shellcode overflowing into EBP over here, this ends up actually messing up stuff big time. And why instructions start getting misinterpreted. So So what we're gonna have to do is kind of extend things a bit, right? I don't know how big it should be, but we're going to start with 16. So our first goal here is to be able to hit the knob sled, right? So one of the things that we're going to have to do is calculate out the address of the name buffer, which we get, right? But then we're going to have to add an offset to it so that it points correctly to address of where the knob sled begins. And actually, while they do give us the address of the buffer, I'm not convinced that this is actually where the contents of the buffer are actually being stored, so much as the address of the address, if that makes sense. Hello, Wild. Yeah. So ultimately, what we're going to want to put into the 4 C's here is going to be the address of the beginning of the knob sled, right? So whatever our address of our A's begins at is going to be where things need to be offset from. So after the fgetS call, our stuff is on the stack. BE20, the address itself, is on the stack, pointing to our actual data. So if we take note, so if we add 32, right? So if we were to go in one direction, it would be BE40. And if we go in the other direction, it's going to be BE00. I forget which because I'm dyslexic as fuck when it comes to the stack. Does it go up or down? Does the address go up or down? You know, it's like, okay, one way or another, we're going to get it. But that shit's annoying. WASM VM. I've never heard of it. But at the same time, I imagine that WASM runs on particular like JavaScript engines. So imagine for a moment that we're going to actually construct a different test scenario here. We're going to just raw dog some knob sled shit right here, right? We do 24 no ops. Followed by actually we'll do 16, followed by Evil Dojo. Actually, we'll do 13. And that way we can have Evil Dojo 666. Actually, even better, we'll do 12 at Evil Dojo 666 in byte string format. Followed by so that's 24 total so far. It really doesn't matter at the moment what we assign to EBP because shit's gonna go out of whack anyway. But the next thing that we have to assign is the actual address, right? Oh, right, this needs to be byte also. So in this case, 20 BE FF FF, right? I'm gonna call this payload test 0. Okay, so I can see the 90s right here, right? So let's step individual instruction. Step. So the EBP loads up our BBB. And we can see the no ops coming up, right? So it's about to execute our no op slide. No op, no op, no op, no op. No op. No op. And now it's getting to the part that says Evil Dojo. So you can see the at EVI. Well, this ends up actually getting interpreted as real machine instructions. That's certain strings actually get processed as like CPU command sequences, which is kind of like an interesting revelation to think about. Because normally you think of like strings as like input. To some other, you know, like predefined set of instructions. In this case, the strings themselves are the instructions. So it's already getting out of whack, but it's actually at the dojo part right now. I'm surprised that it managed to get this far. Still actually executing instructions and it hasn't crashed yet. That's so crazy. Now it's like reading the address as if it were instructions, and it's probably gonna crash here. Nope, not yet. Wow. This is actually bananas. There's a straight up instruction called bad. Oh fuck yes. Let's go. Sig kill. Oh shit, dude. Amazing. We actually got it to like fucking at Evil Dojo 666 injected into the Stack Overflow, caused it to do a sig kill because it was trying to execute straight up a bad CPU instruction. That's fucking funny. I enjoyed that. Fuck, dude. Okay. Oh, no, this is 386. No, we're doing straight old school 32-bit because it's a really good learning tool. And it also scales up rather easily. Once like a student understands the basics, you know, it's only a hop, skip, and a jump to level up to the next paradigm. Not to mention, like, even in 64-bit world, there's like lots of, like, as a good example, like some of the stuff I'm doing here, I'm going to take over into the Redis environment, where I was previously doing research on the Lua vulnerability. I think I made a great realization about how I was generating payloads and how I might be able to actually fix some of the stuff that I was doing over there. Now, so the point of that was to show that we actually successfully execute commands and CPU instructions through that injection, right? Now it's time to actually craft the full deal here. Let's do like 20, right? Or no. It'll be 32. So if we add 32, $40 BE FF. So that should point to the beginning of our no-ops. Now, if we generate this I'm going to do p5.txt. You can see our 90s right here, and you can even see the address pointing to the beginning of the 90s right here. So we got the offset correct. So we're about to leave the my fun function. We're gonna return, and we hit our no ops. Okay. So now's about the fun part. The more fun part. So we got this big long thing here called a shellcode, right? And this shellcode represents these instructions right here, right? We zero out EAX. We push EAX to the stack. And we push a very carefully crafted double word integer long int representing 4 characters, and these are also 4 more characters, and ultimately what it's supposed to spell out is like /bin/sh. In fact, I think the /sh has a second slash in there, which is syntactically valid in bash. But the whole idea is that you execute, or you push this command, and then you set up execvp to actually call the arguments that you pass in. You can actually run any command that might be available on a system. And what better command to run if you've found a vulnerability in a system than to achieve a shell of some sort, right? So how are we going to do that? So what happened? How did we actually get the shellcode, right? We got this program called NASM. And once you NASM, or your net assemble on your assembly code, you get this nice little representation right here. So the first 2 bytes to represent the XOR EAX instruction is 31C0. And then the next byte represents push EAX, which is just 50. Now, something interesting to note here, like if I were to like run a Python program real quick, print char 50, like the character, like the integer 50, and actually 50 isn't even the correct. I should do 0x, right? Yeah. That's actually capital P. So, like I was saying earlier, individual string characters have real world like CPU representation corresponding to like what string they like map to. So like P maps to push EAX, right? Similarly, 53 or hex 53 would be capital S, which maps to push EBX, right? Not everything is going to have something like this, but like for instance, 89 does not have a printable representation, but 68 lowercase h. Oh, and actually, you know, that's kind of part of the string that you're pushing technically. So, okay. At any rate, I've already copied that shellcode into here, right? And we'll get funky with it at some point where we start like doing weird things, because all this is going to do is demonstrate that we're able to like actually run a shell, right? But maybe there's something more that we want to do. Such as like write a shellcode that allows us to run the island command, because at the end of the day, what we're really trying to get is flag, right? And at the moment, flag is totally unencrypted. But how would we actually use it? We got this thing called mdata, right? So the whole idea here is that, remember in the beginning, like I showed y'all, like if you run strings on this, but look, Evil Dojo 666 not found. That's kind of interesting, huh? Now, just for confirmation, See, there's our evil dojo. So the obfuscator works and does what I want it to here. So we can really hide whatever the fuck we want. And I'm gonna have to do something custom in order to do like a check down in fgetS to see if you like input the correct thing, right? Because fgetS will be leveraged to check this thing eventually. But right now we're attempting to recover this encrypted flag. And even then, 1, 2, 3, 4, 5, 6, 12. And 13 technically, because you have to include null bytes. So like, you know, of course, if you run Island on its own, you see that this is what actually gets printed out. And actually, what I kind of want to do is wrap it in brackets. Oh, that's real interesting. So the key is going to be something that also will need to be like recovered somehow in order to like give you a clue as to what the correct solution is, right? But at any rate, let's get back to like actually triggering the shellcode. So we verified that we hit the NOP sled. So now we want to actually put the shellcode in. All right, we've got our program there. Let's also generate a new payload file, and we're going to run that. Here we go. All right, we're going to step once. We're going to step instruction. You can see our A's and our B's right here. We got our A's and B's, as in like ABCs, as in how easy this can be. Note that our address points to our no ops, just like it did before. We're going to step one more time. EVP has BBB loaded in it. We're about to hit our knob sled. Alright, we are on the sled. Let's fucking go. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 14, 15, 16, 18, 20, 23, 24, 26, 27, 28, 29, 30, 31, 32. So first we exhale EAX, EAX. Then we push EAX. Then we push this thing. As you can see, now we have // SH on the stack. Now we got /bin //SH. Then we're gonna move EBX into ESP. Then we push EAX. Then we move EDX into ESP. Then we push EBX. Then we move ECX into ESP. Then we move AL, or rather we move B into AL. Moment of truth. It's going to run the interrupt handler, which will trigger whatever system call is loaded into the parameters. And we should get a shell out of this. I don't know how GDB is going to play with this when it happens, but let's see. Oh shit. Process is executing new program. It actually executed dash. Interesting. Inferior one process exited normally. Okay, so it like shot a brick. But we can actually test it by feeding P6 into it. Illegal instruction, core dumped. What? Oh, is it user bin sh? Is that the problem here? Oh, okay. /USR /BI. Okay, so here's what we're going to do to fix that. We're going to calculate out the string necessary for Alright, so this first part is like //sh. And then this is like /bin, right? So we need a new one. And this is gonna do /usr. So the first slash is right here, 2f. Then we have a 75. And we have a 73. And a 72. And there's our new thing right here. Right? So some of these will be very similar with the original shellcode, right? Alright, then new ones. 6, 8. 2f. 7, 5. 7, 3. 7, 2. And then I think the rest is the same, right? Oops. Yeah, it is, I forget which C++ it is. It's, It's whatever default is, actually, because whatever default allows for constant expression. Okay, well. Illegal instruction again. Why is my buffer overflow telling me illegal instruction? I suppose that is the question, right? But in addition to that, like, what if I wanted to create a shellcode that actually executed my island function, right? We're trying to get to the island after all. And when we run the program, we're given the address of island. But just like with any other function in C or C++ at the assembly level, when you're jumping into a new frame or when you're jumping into a function or you're about to call a function, you have to push the base pointer in like preparation for that. Or rather, yes. Or you move something into ESP, right? Like, so before we actually call island or we load an address or anything like that to be called, or better yet, we could probably like just like do a jump instruction, right? Like if we have the address, we should be able to just like jump to an address, right? But we do need to push EBP and then move ESP into EBP. And then we also have to allocate some space on stack. I wonder if it got the which I thought it is int 80 indeed, right? Oh. Interesting. Okay. Is that actually supposed to be move? EAX11 instead of AL? Oh. That's why that won't work. Wait a second. Is AX even a valid register? It is. but unfortunately that instruction involves a 0 byte, which we can't have any 0 bytes in our shellcode. I suppose that's why they were doing AL, right? But unfortunately, it keeps yelling at us that this ain't correct. This is an illegal instruction. Oh, that's clever. Okay, here's how they get around this. C0 50 68 2F 7368 68 2F 6269 6E 68 2F 7573 72 89 E3 50 89 E2 53 89 E1 6A 0B 58 BD 80. All right. Illegal instruction again. XOR. All right, so there. Oh no, it didn't push. It did. Wait. Oh no. It did push the whole thing. Okay. Okay. So we got our whole thing right there. I wonder if it's fucking up because we nuked EBP. Process is executing new program. What is dash? Oh. It's the command interpreter, huh? Okay, so running it from the command line works. But for some reason, even though it all glances, it looks like we're doing this correctly. Something. We actually don't do anything with ESI here. I wonder if that has if that's part of the problem. All right, let's do this one more time. Six A 0B. $58. 31 F6. 56. $68 2F. 2F 7-3. 6-8. 6-8 2F. 6-2 6-9. 6E. 6-8. 2F. 7-5. 7-3. 7-2. 8-9. E3. 31 C9. 8-9. PA. PE80. Son of a fucking bitch. Why? Wanted to call exec V. I think we're about to hit 2026, y'all. Oh. Wait. Okay, so EBX now points to it. So it's the first parameter. Syscall. Command to execute. Right? Zero. Zero. int 80. So as an example, if we wanted to like cleanly exit, right? Super basic, right? Not nearly as complicated as this one. My animals don't like all this noise. Oh, hey! Happy New Year! There you go. Oh, oops. Uh-oh. Did not like the, Oh, you know what we could do for that? Isn't there like an increment in x86? Oh, is it just ink? All right, let's try this one. Three one B0 40 31 BB CD 80. All right, that worked. That successfully exited without like dying. Okay, well there it actually didn't work. But inside of GDB, it exits normally. But when running it outside of GDB, it is crashing. So that's interesting. And I'm getting sleepy. I'm an old man. And I've been doing this for a couple hours already. Progress in this kind of domain is very slow. It's not like game dev at all. It's like very, very detail oriented. Well, we've made some progress. We didn't get as far as we would have liked. So, one of the things to note, too, and actually maybe we can account for this, is because we're actually executing inside of my fun, like, any sort of prep work for calling some other function, we might need to actually push EBP in preparation for that, right? What was the actual prep that we have to do? Move ESP into EBP. That was 55. 89 EC. And the rest is the same. No, it's still doing it. Fuck. It says it's exiting normally here. And it says it's executing here correctly as well. So I'm not sure what's actually triggering the cause for the illegal instruction. I'm not just coding an assembly, I'm actually shellcoding. So you see all this kind of stuff right here, right? Like we're crafting shellcodes that are designed to execute inside of a buffer overflow attack. And the whole goal is that you want to get a shell, right? Like you want to be able to run a command like bin/sh, right? Like we want to execute this by inside of another program by injecting these shellcodes. It's kind of security 101 in a lot of ways, but at the same time, like properly pulling this off requires a very crafted environment. And not to mention, what I'm doing here is very bare bones, you know, like what I ended up having to do in order to get this to compile at all, or to get the because here's the basic program, right? Like this is the C program that we're attempting to infect. Our input gets fed in through here, so like over here on the right, what happens is you run program, right? And we give you some pieces of info in this very specially crafted environment where most of the protections are turned off. So, you know, like there's a lot of stuff that like C and C++ gives us out of the box that would otherwise help prevent these sorts of attacks, but for demonstration purposes, turn them off so that we can actually achieve command execution. And I'm able to actually run our own instructions through the use of these shellcodes, right? So this is assembly, but like what we actually want is machine code. And to get the machine code, here's what you do. First, you assemble your assembly, and then you dump the bytes of that assembly language code. And that's right here. Then you just piece them together as a string in a language like Python or something. And then automate or write a small program to like generate full payload, and then feed it to your program that you're trying to break. So as an example of this, right? I'm probably gonna go to bed soon, but let's do this again. Because watching the knob slide actually trigger is kind of satisfying. So I'm gonna break on fgetS, right? And then we're gonna run our little special mini exit, right? That's designed simply to just cleanly exit the program. So here's the debugger, right? Like we get to see all the CPU registers. We get to see the state of the stack. We get to see what instruction we're currently executing. See, it stopped on fgetS because I told it to breakpoint there. So we're going to step past fgetS to the next instruction. So, as I showed you earlier, this is actually the fgetS right here. So what happens after the fgetS? Actually, right here is it prepares to leave the function. Now, as you can see, we've got this big long thing right here because what was that? Well, over in terminal, let's print out. So this is actually what the payload looks like after we generate it. This is actually what the bytes of that payload look like. You see those 90s? Those are hex 90s. And they represent a no operation instruction. So what we're doing is called a no op slide. Oops. See, we just hit our no op slide right here. And there's a bunch more of those. But then at the very end is our shellcode. So we'll see it hit 5589. Right there. Boom. Oh, I see why it's probably breaking now. Because because our original EBP was incorrect. So I bet that if we, instead of writing BBB into the ESP or into EBP, we copy the address that was originally preserved. And the program probably won't like shit a brick. That's probably the real reason it's yelling about illegal instruction as well. It's because we're mangling EBP when we do this. I mean, it's exiting normally. Here, anyway. But not here. And it probably does have to do with the EBP situation, right? So, like, we have to take note of what EBP was. On hitting fgetS. 08. right? Oh. FFFF BE BE 08. So that preserves the original EBP, right? Before it actually calls fgetS. Okay, so it terminates after the interrupt gets called. But we're still core dumping here. This makes me sad. I didn't want to leave off on like this. It's getting late though. Heart bleed all over again. Yeah. Something in that direction. There was a Mongo bleed. You might check that one out. So much to do in the security space. You could really spend a lot of time here and never escape. I hope y'all have enjoyed tonight. I'm gonna have to put together a big ass montage of all of my game developer footage from the last few months. There's a lot. Thank y'all for joining. I think I'm gonna go and take a break. See, what happens when you run it in normal mode, it just simply crashes because we don't even get to run a illegal instruction in this version because we're running in 64-bit or rather we're running with ASLR. So the progression here would be like getting the like demonstrating full manipulation over the overflow capabilities. So in other words, not only being able to successfully do the system calls, but also being able to jump around the program and call other functions within the program, as an example. And so the next level after that would be to re-enable ASLR and be able to demonstrate that you can generate payloads that successfully demonstrate the same effect, even though you have address space randomization. Being able to pull it off in that environment and then reintroducing each additional protection and then evolving your payloads to account for these protections, right? Like there is a realistic way to upgrade and learn from this angle, but it's all practice. And while I've definitely confirmed that I'm triggering something, because that loop got detected, I wonder if that also has anything to do with it. But there's some protection that's in place that's keeping us from properly executing. I thought I turned everything off here. I wonder if I have to be root. Oh, wait. All right, here we go. Segmentation fault. Core dumps. I thought it was illegal instruction. There we are. Okay, that's illegal instruction. I wonder if it's Bash that. I wonder if it's ZSH that's doing all that shit. Right? Well, no, we're running Bash. Huh? Oh, that's interesting. Illegal instruction. Oh, was it Octo? I thought it was Jewbird. All right. Well, you're gonna get hidden, so that's fine. But yeah, I'm out of coffee. I'm out of water. I'm gonna have to re-up on all that stuff anyway. Alright, what was I doing? Illegal instruction. Core dump. Even with the exit system call. Oh yeah. But yeah, people definitely shouldn't be putting other people's personal information in their own DNS. Especially if you don't want to get like doxxed yourself. I think if you bring a gun to a gunfight, that you can't really, you know, blame the other person if they also bring a gun. You can't bring a gun and then be like, oh my god, I can't believe that you would bring a gun, and then, you know, it's like this really weird attempt at like gaslighting and psychological manipulation. I just don't play that shit. Like, I'll fuck you up in real life. Like, this ain't a game. It's a real fucking life. And you can play my game in alpha. That's definitely true. A lot of people really like how this thing looks. They like to see me working on it. They like to see where it's going. That's a lot more than you or anyone else has done. Especially if you feel like, you know, you're gonna take the time and come into my chats and try to at me. That's a no-no. But getting me to do anything, no, I choose to do whatever the fuck I want to. But if you're going to choose to be ugly with me, then I will absolutely choose to be ugly with you. In fact, I'll be uglier. I'll be ugliest. Because I am a mirror, baby. And I reflect what the world gives me. And if you give me good vibes, then I will amplify them. And if you give me negative vibes, and you don't give me a choice, then I will outshine your own negativity. And I don't think that's what you want. Unless that's what you're trying to get me to do. And if you're trying to get me to do that, then I'm just gonna remove you from my life, because I'm not really interested in projecting that. However, if you back me into a corner, then I'll punch my way out. You can count on that. I've done it before. Ask me how I know. But you can punch your way out of a lot of corners on itch.io. Go do that now, before it's too late and I decide to take the game down and you can never play it again. What a terrible thought. Take it easy, everyone. And Happy New Year. Happy 2026. Let's make it a good one.